In this lesson, we're going to continue looking at measurement and converting between units, but we're going to look at the metric system in this lesson. I thought I would show you the definition of what a meter is. And what's interesting is that although I typed in meter, M-E-T-R-E, and it even came up as in the definition as M-E-T-R-E, the definition gave it to me in M-E-T-E-R. Note that the E-R is the American spelling and R-E is the British and Canadian spelling. And it's interesting because the meter hasn't always had the same definition. Initially, it was 1/10,000,000th of the distance from the equator to the pole, measured on a meridian. And then it became the distance between two lines on a platinum iridium bar, the international prototype meter, which was or is still in Paris. And it then became defined by wavelengths of krypton 86. And it's now defined as a fraction of the distance that light travels in a vacuum in 1 second. And I won't even try to read you what that fraction is. Anyways, that's quite interesting how that has changed slightly over time, although they all are so close to being the same measurement. When we use the metric system, we always use these prefixes. So kilo, which means 1,000, hecto, which means 100, deca, which means 10, deci or deci, which means 1/10, and those two are easily confused. Centi, which is 100th, and milli, which is 1,000th. And these prefixes are really important for you to know. And all of our conversions will be done using these. One of the nice things about the metric system is that once you know those prefixes, you can do any type of converting between units because it's always just a matter of multiplying by powers of 10. You never need to, for instance, remember that there are 4 quarts in a gallon. You just need to know that centi means 1/100th of a meter or a liter or a gram. So let's look at these conversions and practice them. I've included a little chart from your textbook here as well, and it would be really useful for you to have one of these on a cue card, for instance, and use it as you're doing conversions. So in our first example, we're converting 3.6 kilometers or kilometers to meters. I believe that kilometers is the correct pronunciation, but I think most people say kilometers, at least in this area. If I'm going from kilometers to meters, I'm moving 3 steps to the right on this chart, and so I'm going to just show that way, which means that we're actually multiplying by 1,000 or moving our decimal place 3 places to the right. That's what makes metric conversion so easy. So write out the number that you're using, and if you need to, add zeros to the end for moving to the right at least, and then think about moving that decimal place 3 spaces over. So the new decimal place will be after the second 0, so we could say that 3.6 kilometers is equal to 3,600 meters. I'm going to just switch to a slightly thicker pen so that my decimal places show up a little better. Okay, so 6.2 meters to millimeters. Again, meters to millimeters is going to the right on our chart. I'm going from 1 meter to millimeters, which are very small things, so I'm going to have more of them. That's another way to think about it. I'm going 3 steps to the right, which means I'm multiplying by 1,000, and you can see that that's 10 to the power of 3 Okay, that exponent on 3 on the 10 is important because it shows how many spaces we're moving over the decimal place. So again, write out your number. If you're multiplying, add some zeros to the right, and then move this decimal place over that many spaces, and that tells you the new space for your decimal place. So 6.2 meters is equal to 6,200 millimeters. And let's look at the next one where we're going from meters to centimeters. And this is centimeters, meters, kilometers, millimeters. Those are the most common measurements used. And those are the ones that really you should have memorized. We very seldom use hectometers or decameters, or decimeters for that matter. So I'm going 7.2 meters to centimeters. I'm going 2 steps to the right, or I'm multiplying by 100, or by 10 to the power of 2. So 7.2, I'm going to add a 0, and I can see now I have space to move that decimal place 2 places. So 7.2 meters is equal to 720 centimeters. Never leave the version that has the arrows as your final answer. Always rewrite your answer with the correct units as your final step. When we go from small units to larger units, we're actually moving to the left on that chart, or we're dividing by a power of 10. So if I'm going from 127 centimeters and I'm going to meters, I'm going 2 steps to the left, or I'm dividing by 100, or dividing by 10 to the power of 2. So I've got 127. Any whole number, the decimal place is at the right. So we're moving the decimal place 2 steps to the left. So we end up with 127 centimeters equals 1.27 meters. And let's look at the next example, 78 millimeters to kilometers or kilometers. I'm actually going 6 steps to the left. So I'm dividing by 1 million. Got to make sure I draw the right number of zeros there. So I'm going to write out that 78, and since I'm dividing, I'm going to put a bunch of zeros in front of it, and then start moving the decimal place. So 1, 2, 3, 4, 5, 6. So I'm going to have then 78 millimeters is equal to 0 decimal, and 4 zeros, 7, 8 kilometers or kilometers. All right, so we will do one here with hectometers or hectometers. And a hectometer to a meter is 2 steps to the right, or multiply by 100. So I'm going to move that decimal place 2 spaces to the right, so 65.26 hectometers equals 6,526 meters. Question G is asking us to add some measurements together, and notice that they aren't all in the same units. We've got meters, kilometers, and meters. So it's important to convert them all to the same units first. So let's convert the one that's different, the 1.5 kilometers, and convert it to meters. So let's do this conversion now. So 1.5 kilometers, oops. We're multiplying by 1,000 or moving the decimal place 3 spaces to the right, so that'll give us 1,510 meters. So now we can do our adding. 136 plus 1,510 plus 990, and that will give us 2,636 meters. If we needed to have our answer in kilometers, we could then divide by 1,000, and we could then get to 0.636. 636 kilometers. Metric volume is based on the liter and uses the same prefixes and the same method of conversion. So you could use the same chart that you were using before when you're doing those conversions, just replace meter with liter. And so in this case, we're going 0.326 liters to milliliters. So we're going to the right 3 or multiplying by 1,000. So 0.326 liters will give us, if we move that decimal place 3 spaces, we'll get 326 milliliters. Note that we use a capital L for liters. And likewise, 6.7 liters to kiloliters means that we're dividing by 1,000 or going left 3 spaces. So again, we'll take that 6.7 and we'll put some zeros in front so that we have space to divide by 3 or to move the decimal place 3 spaces. So we'll have 6.7 liters equals 0.0067 kiloliters. And finally, metric weight is based on the gram. And again, we have all of the same prefixes and the same method of conversion. There's one new unit though, and that is a ton. Lowercase t is the abbreviation for it, and a ton is equal to 1,000,000 grams. And it's also helpful to know that a ton, what that is in kilograms. And it'll be 1,000 kilograms, okay? We don't use the in-between measurements as much with weight. So we'll use tons, kilograms, grams, and milligrams, and we won't use the ones between those nearly as much. So let's do some conversions. 2 tons to kilograms. Well, tons are 1,000 kilograms, so we're actually moving to the right 3 because we're multiplying by 1,000. So 2 tons is equal to 2,000 kilograms. And let's move on to milligrams to grams. We're going to the left 3, so we're dividing by 1,000. So again, we can put a bunch of zeros in front of what we've got and move that decimal place 3 spaces. So 83.4 milligrams is equal to 0.0834 grams. And the last example here, 678 kilograms to tons. We are actually going to the left 3 or dividing by 1,000. So we can actually do it right on the example there. If we move the decimal place left 3, you can see that 678 kilograms will be equal to 0.678 tons. Our final question here is actually a rate or proportion type of question. And we've got, if coffee costs $12 for a 350 gram package, how much does it cost per kilogram? Since we want our final answer to be in kilograms, it makes sense to convert the grams to kilograms. So 350 grams equals how many kilograms? Grams to kilograms means we're moving left 3 spaces or dividing by 1,000. So we're going to get 0.350 kilograms. We could now set this up as a proportion. We could put our money on the top and our weight in kilograms on the bottom. So $12 for 0.350 kilograms is equal to X, or whatever letter we want to use, for 1 kilogram. So now we can do our cross products, and or X over 1 is actually equal to X. So we can just divide 12 by 0.35, and we'll get X equals, and we'll put our units in right away, $34.29 is the cost per kilogram. And that's the end of this lesson.